I hope you have taken a break and, gotten familiar with what we are doing. As I said, today is going to be intense because I want you very early on in this class to really get a feel for finance. I mean, to me, the beauty of finance, as I keep saying so, is not the formula. It makes so much sense. And once you get a hang up of why we are using an Excel and why we are doing the formula, you'll get a sense of that, and it'll be very, very easy for you to recognize the value of each. I have nothing against Excel, but here's a simple reason we use Excel, is because we don't have time to calculate all these numbers. We know how to do it, but we don't have the time, and it would be a pretty bizarre thing to calculate numbers for the heck of it. The second reason is these cash flows in this problem are fixed. They could change. That's what life is, and we'll do that later in the class. But two aspects about it. Most examples of loans or retirement funds are very realistic in this respect too, i.e. the C is fixed. People choose to operate like that, whether it's convenience, whatever, and loans many times are fixed rate loans. So what I would encourage you to do is recognize that these are simplifications at some level, the C being a fixed number, but at the same time, see, it's not a simplification of real life. And we'll get to more complicated things. Why am I bringing this up? Because if we didn't have compounding, we wouldn't need Excel. And if we didn't have things changing over time, we wouldn't need Excel. So Excel is awesome, but keep it where it is. It's not controlling you, you control it. Okay, let's move on to the second phase of an annuity, which is present value. So again, there's this chart. I would like you to look at it for a second. Same thing, just to make life simple. What I'm going to do is I'm going to stick with the same example of 3 years. And by the way, as I'm doing this, I want to thank, instead of just thanking once, I want to multiple times thank my colleagues. I went to University of Chicago for my PhD, and before that I've studied a lot. I have to thank so many people for showing me the beauty of finance. I also want to thank my colleagues at University of Michigan, Ross School of Business. Ronan Israel is one of them who, with me, taught this introductory class many, many years ago. And he has been a big influence in how I think. And then there are a lot of other colleagues like MP Narayanan, who's a great teacher. I want to thank all these guys for letting me become who I am. And if I'm worth anything, it's due to other people, not due to me. Okay, so let's get started. The first cash flow at year 0 is 0, and not because it's forced to be, it's convention. And in this case, remember, because it's present value, I'm standing today, I'm doing the opposite of future values. So I'm saying not years to the end, years to discount. And the word discount is coming from a very simple reason, and the R is greater than 0. Because interest rates are positive, future value grows. But because interest rates are positive, the future is discounted when you bring it back today, right? So how much? 0 years of discounting, because we are standing today and present value today is 0. What is the present value? Turns out to be 0. Why? That's simply because there's no cash flow here. If there were, it will be exactly the same number because of no years to discounting. So in some sense, years to discounting is a key variable. Now here, things are a little bit simpler. 1, the first C is 1 year away. 2, 3. So because we have done this table before, I'm not going to spend too much time on it. However, recognize that we are doing the exact opposite of what we did last time. And the reason we are doing present value after future value is, in my book, if you understand future value, you understand compounding. And then when you come backwards, you're not thrown away by why you're dividing by 1 plus r, 1 plus r squared. So let's do it. This is C over 1 plus r. And the neat thing is we have done this last time. Only thing is we have to do it 3 times. C Why am I putting 1 plus r each time in parentheses? Simply because it's the 1 plus r is the factor, not 1 outside or r outside, anything like that. 1 plus r is the factor, and the reason it's getting squared and cubed is because, pause again, compounding, right? So once you recognize this aspect of it, I want you to bear with me for a second, and what I'm going to do is I'm going to go to another page where I actually write out the formula. And again, I'm not going to try to simplify it. Simplifications can be done very easily by you, and in some sense it's useful to do it. So let me write out the present value formula. The present value formula for a 3-year annuity, and I use this 3 just to remind me that it's just 3 years, is what? C over 1 plus r plus C over 1 plus r square plus C over 1 plus r cube, right? So I have just to do 3 PVs. Now remember, these PVs are not easy to do, right? So that's why I'll at some point use a calculator. And remember, I can replace this by PMT in my head. In textbooks, we don't use PMTs, we say C because C is a generic word for cash. The other thing is C's are fixed, and that's because of the nature of the beast we are dealing with right now. Okay? Now let me show you that actually I can take C out and have right? Pretty straightforward. So what is this? If you think about it a little bit, this is a factor again. And it's a present value factor of an annuity. Of what? What is the annuity? $1. So if you know the present, if you know this guy, for which what do you need to know? R and N. How many years and what's the interest rate? If you know the value of $1 paid 3 times, you can know the value of C bucks, whether it's half a buck or it's $100. That's the beauty of it. How does this formula change if we go to PV of N? Simple. One thing changes. There's a bunch of dots plus 1 over 1 plus R raised to power N. So you'll keep going till you arrive at N, right? I hope this is clear. Again, why am I doing this? I first did the concept, then the formula, but I'm really, really interested now in doing problems. And again, I repeat, if you need to pause now, it's good to do it, because I do not want you to get overwhelmed by formulas and so on, okay? So let's go on, and I'm going to even pause for a second to remind you, you don't have to keep watching the video. Take a break, and let's do one problem at a time.